All right, so picking up with number 18. Number 18. All right, it says that a point in rectangular coordinates is given. So rectangular coordinates is given -5, √3, comma, lost my place, comma 5. It's now asking us to convert the point to polar coordinates and find the exact values. So if this is currently in rectangular form is always xy form. So if we know more clearly that x is equal to -5 √3 while y is equal to 5, my job is to figure out what's r and what's theta. Because my job is going to be to put this in r comma theta. That's what polar form is going to do for us. So remember that we have ways to get there. We have these little conversions that are going to help us along the way. So the first conversion, if I'm trying to find r, we're going to use the fact that r squared is equal to x squared plus y squared. Right? So just a whole bunch of substitution that needs to occur here. We'll say that r squared is equal to x squared plus y squared. Well, remember we said that x was -5 √3 and y is 5. So to evaluate it, we'll get that r squared is equal to, let's see, -5 squared is 25, √3 squared is 3, 25 times 3 is 75. Does everybody see how we got there? All right, and then finally, hopefully this is the easier one. 5 squared is 25. Combine those. Now we're saying that r squared is 100. Square rooting both sides, we know that r is equal to 10. Jumping over to the the theta side of things, now we can say that the tangent of theta is equal to y over x. So more substitution is in store. We can say that the tangent of theta is equal to y over x, while y is equal to 5 and x is equal to -5 √3. So is there a cancellation that can take place? Possibly simplify things? 5s are out. So we can say that the tangent of theta is really equal to, I'm just going to bring the negative out front. So 1 over √3, which we might see that a little bit easier if we rationalize as -√3 over 3. Again, it's debatable as to whether or not that last step was necessary, but we're going to say that theta is going to be equal to the tangent inverse of -√3 over 3. So the first thing, before we focus on the values, if tangent's negative, which two quadrants could we be in? I'm going on. 100% great? Maybe. Okay. Sorry, what was that? I think I heard 2 and 4 is where tangent could be negative. Good. So if tangent, again, if we're talking about being in quadrants 2 or 4, could we solve that debate right now before we actually consider the math? We go back to the original problem. Honestly, we could have started here. Which quadrant are we in? I went left and up. We're in the second quadrant, right? So the reason why I would go through that is if we know that we're in quadrant number 2, think about on the unit circle. We are in search of, specifically in the second quadrant, where in the unit circle does it happen that the tangent of theta is equal to -√3 over 3? What are we thinking? Where's that going to happen? 5 pi over 6, isn't it? Okay. Now, if we think about, well, how did we get there? Think about what -5 pi over 6 is. We're talking about -√3 over 2, comma 1/2. We know that tangent is the sine over the cosine. And when you're dividing fractions, that's really like multiplying by a reciprocal. Something like this, at which point the 2's cancel, and then, yeah, we have it right there. 1 over, -1, over √3. And we're there. So all this work just showed that theta is equal to 5 pi over 6. Quite a while ago we said, lost my place here, but we said that r was equal to 10. So putting that together, r comma theta, r is 10, theta is 5 pi over 6. Okay, questions on that one? So we asked about one more. Number 19 was the last one that you guys asked about. We can surely hit more here, time permitting. But number 19 was actually one that I have circled on my sheet as far as make sure that we talk about this. I know that we talked about it yesterday, but again, we want to make absolutely certain that we know exactly what's happening here. So let me get this stuff written up, please. All right, so it says that a point in polar coordinates is given. 7, comma, negative 2.34. We want to convert the point to rectangular coordinates. No, wait, hold on. As I said this, I'm remembering. Yes, this was on the sheet that we wanted you guys to complete yesterday, but we actually didn't get to this problem in class. I podcasted it. Maybe you watched it last night. Maybe you didn't. I'm assuming that you probably didn't know. But it's going to be good to hear this. If we know that we are in polar form, that means that we know r and we know theta. So that tells us that r is equal to 7, theta is equal to negative 2.34. So we know what r is. We understand how that's going to be a distance away from the pole. But what is theta? It's an angle, right? Is this angle measured right now in degrees or radians? And I know that, and you guys just answered radians, and you're absolutely right. Maybe I'll ask this question next. How do we know it's not in degrees? Because there's no degree symbol. Guys, it's really that easy. If there's a degree symbol, it's in degrees. So your calculator has to be in degrees, and you go from there. If there's no degree symbol, then you must be in radians. Okay? I get it if you're a little hung up on the fact that, well, wait a second, we're radians, aren't we used to like, pi over 6, pi over 4, pi over 3, 7 pi over 6, things like that? Those are great. Again, those are what show up on the unit circle, and honestly, those are what we use the majority of the time. But negative 2.34 is still a radian measure. So we have to use it as such. Does that make sense? So the biggest issue or problem with this problem, I'm absolutely certain of it, is that people don't see a recognizable radian measure, like I said, pi over 3, pi over 4, something like that, and they start thinking degrees and they just use their calculator in degree mode, and we get the problem wrong. Okay? So as long as we're doing this properly, I think that we should be okay. Again, my job is to figure out what x and y are equal to, because we're going to get an answer in x, y, rectangular coordinate form. So luckily we have conversion formulas. We know that x is equal to r cosine theta. So if we do substitution, we know that r is 7 times the cosine of theta, which is negative 2.34. And as long as my calculator's in radians, and I know that I keep on referring back to the calculator, but this should be an easy problem if your calculator is set up properly. What do we end up getting there for x, please? 4.87? Yeah. Sound about right? Okay. Similarly, for sine, we can say that y is equal to r sine theta, almost the same problem, but now y is equal to r is still 7. We're going to multiply this now times the sine of theta. Theta is still being negative 2.34. And again, it's all about setting up your calculator properly. Once we type that in, what do we get for y, please? Negative 5.03. We know x, we know y. We can put this together, negative 4.87, comma, negative 5.03. Now, which quadrant is that in? Third quadrant. Could we figure out approximately, and again, this is all assuming that you have like plenty of time, plenty of extra time on your test, which maybe you will, maybe you won't. But do you know on a circle where negative 2.34 radians is? I would assume most of us would answer probably not to that. But could we convert it to degrees? We know how to do that? Sure, you should, right? Just going to multiply it by 180 over pi. Okay? That's going to put you in degrees, and I'm certain that it's not going to be a perfect degree method. But if you know how many degrees that is, could that tell you which quadrant you're located in? So this is a way of checking which quadrant you're going to be located in. And based on this answer, I'm pretty certain, even though I do not have it written down or anything, I'm pretty certain that we're going to be in the third quadrant. In fact, we better be in the third quadrant if that is the case. Okay, so I'm going to be given negative 90 to 180 degrees, somewhere in there. Again, just did it, James, you said? Negative 134. Perfect. That's going to put us in the third quadrant. All right, guys. Any other last-second questions? All right. So, again, there are no additional assignments. I'm going to stop this podcast.